Okay, the next part, or the last part of our triangulation unit is going to be looking at something really off center or way off center, or something of strange shapes. Okay, now we talked about how we're triangulating from plan view when we first start off, and that's where we're leaving it. So really the difference now, when something becomes really off center, is just trying to draw the plan view. And that's really the hard part. The process of triangulation is exactly the same. There will be a lot more lines, and the lines will be more complicated in different lengths, but really, once you have a plan view, there's no different. So if we look at something really oddball, I don't know, let's throw something like this. I square it around, and there's no line of symmetry anymore. And there is if we went something maybe through here, but nonetheless, we're not going to split it up in that way. We're talking the quadrants and things. So to break this one up, if we started from here, and getting from an elevation view, which is the way that we normally see a project, to this one, there's going to be a lot of indicators on that drawing. It might be flat on top, flat on bottom, might be down 1, down 2, up 3, whatever, but you'll find all those things. And when I do that, I'll draw one shape first, usually the square if I have a square, rectangular side, and then from center, and I'll base things off of all those edges, okay, and then I'll come up with my plan view. But from there, again, we're particularly in a squared around, we're looking at the 4 quadrants, and the lines within those quadrants, the element lines, have to be associated with the corresponding corner. Okay, so if we had our divisions in the lower right quadrant here, those would all go back to this corner here. Okay, lower right to lower right. And the one, the lower left, would go to the lower left. And you can already start to see a bit of a shape in there. Upper right will go to the upper right. So we start to get in here. And it takes on a 3-dimensional shape. These would be hidden lines, of course, but they would all come back to here. Okay, then we have our plan view and element lines. We just transfer all of those into a true length diagram, and then build the project just from there. Okay? So corresponding corners or portions, quadrants, whatever it may be, need to be connected in our plan view. Now what if we did something, say a circle to a triangle? We could build that, no problem. All we need to do is establish a plan view. But in this case, we don't have 4 corners like we did on the square or rectangle. We only have 3. So we want to envision things, how they would actually join together. If we imagine that shape, it's round and then it's turning into a triangle up top. Well, we got to split it in some sort of a way that we can accomplish that, right? And in that case, it may be thirds. So we want to divide our circle into thirds. And we would start connecting things up that way. Okay, so these would start going in like that. And connect those through so that they make sense in some way. So we could take our 12 divisions, depending on how the triangle is orientated, we would take those 12 divisions and orientate them in a fashion that everything would come back to a certain point there. Right, something like that. The end result, though, is going to be, as long as we can actually physically make it, as far as bending it and forming it, we can draw it however we want. Okay, so this one would transfer into some weird looking shape. We can take maybe a square this way, and maybe we want to do a twisted fitting. We're going to twist one out that way, but instead of just joining those corners, maybe it's got a corkscrew kind of effect to it. Okay, we can do that as well. Just connect the corners, make triangles out of everything, and you'll start to see that those all connect. Triangle, 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 over and over, right? And then you can build that part by triangulation. Parallel top and bottom. Okay, the ends need to be parallel for us to use plan view triangulation. Other than that, you can, the sky's the limit. You can draw whatever shapes you want and triangulate that. It actually, you can make really weird shapes. We can go square to oval. Okay, we would divide it just the same. It would be just exactly the same as a squared around. But the shapes, we're not limited to what those are. Octagon to round, octagon to square, rectangular, elliptical, triangular. It doesn't matter. You draw those two shapes out in a plan view and divide them, and then connect them in a way that makes sense that we can form it. Okay? I've seen some really cool projects where people have taken something like a round to round or a square to round and made like table legs, right? You make a really elongated fit-in or a table base. A twisted fit-in is a really neat one to see as a table base, or 4 legs, big stumpy legs. But you might take some sort of a square and then have one so that it's like a piece of straight duck that you twisted, right? And we call that a twisted fit-in. But as long as the top and bottom are parallel, the two ends, we can do that. Okay, so you're not limited by the shapes that we choose. We can choose whatever we want when it comes down to it. Is it realistic when we look at HVAC fittings? No. But if you come across a fitting that's really weird, or you need to get around an obstacle and you need to create some fitting, don't be intimidated by it, because if we can get those two ends parallel and then just create whatever shapes you want on the outsides, get that plan view drawn, and then see how it will connect one another in means that is actually, we're actually able to fabricate it. Okay, so try one a square or something. Just imagine 2 different shapes and then connect them and make a pattern for it. Try that out of cardboard and see how it comes together. Okay? Thanks.